One of the landmark discoveries of 19th century physics was the realization that electricity, magnetism and light are all connected. Experiments had already showed that the movement of electric charges appear to produce magnetic fields, but the exact mechanism behind this remained mysterious. It was a Scottish physicist, James Clerk Maxwell, who proposed that these charges were exerting influence through the form of radiation, so-called electromagnetic waves, which he proved were traveling at the speed of light. What is electromagnetism? Electromagnetism was first realized in 1820 by Hans Christian Ørsted. In his setup, a battery was used to supply electric current to a compass. Whenever the electric current was switched on and off, the needle deflected from the magnetic north. This activity convinced Ørsted that magnetic fields radiate from all sides of a wire carrying electric current. Electromagnetism or electromagnetic radiation is a fundamental force in nature consisting of the elements electricity and magnetism. It is a form of energy that is all around us and takes many forms such as radio waves, microwaves, X-rays and gamma rays. Sunlight is also a form of electromagnetic radiation, but visible light is only a small portion of the electromagnetic spectrum, which contains a broad range of electromagnetic wavelengths. Electromagnetic radiation is created when an atomic particle such as an electron is accelerated by an electric field, causing it to move. The movement produces oscillating electric and magnetic fields which travel at right angles to each other in a bundle of light energy called a photon. Photon travels in a harmonic waves at the fastest speed possible in the universe, almost 186,000 miles per second or 300,000 kilometers per second in a vacuum, which is also known as the speed of light. When asking what electromagnetism, one of the four fundamental forces of nature, does, it is perhaps easier first to say what it doesn't do. It doesn't keep our feet on the ground, Earth swinging around the sun, or the stars and galaxies in the universe moving on large scales. This is a domain of gravity. It doesn't bind fundamental particles together in the atomic nucleus or determine their decay. The strong and weak nuclear forces do that. But pretty much every other phenomenon that happens on a scale between those two depends on electromagnetism. As such, electromagnetism is essential for far more than just electricity and magnetism. It is the force that binds negatively charged electrons to positively charged atomic nuclei, ensuring that stable atoms can be formed and that chemistry, including the chemistry of life, can happen. Electromagnetic fields are present everywhere in our environment but are invisible to the human naked eye. Electric fields are produced by the local build of electric charges in the atmosphere associated with the thunderstorms. The Earth's magnetic field causes a compass needle to orient in a north-south direction and is used by the birds and fish for navigation. It is also responsible for all sorts of everyday forces such as friction that ultimately result from the interaction of electrons at an atomic level. Most obvious are the two from which the forces derive its name, electricity and magnetism. These were the subject of much investigation and experimentation by 19th century physicists such as Michael Faraday and James Clerk Maxwell. It was Maxwell who in the 1860s showed that electricity and magnetism are in fact two aspects of one unified phenomenon. Moving electric currents cause magnetic fields and magnetic fields induce electric currents to flow. Maxwell also saw in his classical theory of electromagnetism that electric and magnetic fields always propagated at the same constant speed, the speed of light or c. This takes us to the nub of what 20th century quantum field theory revealed electromagnetism to be. It is the fundamental force that acts between all particles that possess electric charge, positive and negative. Like charges repel, whereas opposite charges attract. According to quantum electrodynamics or QED, the quantum field theory that now explains electromagnetism, its force-carrying particle, its boson, exchange between all charged particles is the photon, the quantum of light. Photons of different energies are associated with waves of different frequencies, and the electromagnetic spectrum is the name given to the gamut of them all. The electromagnetic spectrum is generally divided into 7 regions in order of decreasing wavelength and increasing energy and frequency. The common designations are radio waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. Typically, lower energy radiation such as radio waves is expressed as frequency. Microwaves, infrared, visual and ultraviolet lights are usually expressed as wavelength, and higher energy radiation such as X-rays and gamma rays is expressed in terms of energy per photon. Light with the longest wavelength, millimeters, meters or even kilometers across, takes the form of radio waves. On the other side of a spectrum, light with wavelength slightly shorter than 380 nanometers is known as ultraviolet. Beyond that come X-rays, and beyond that still come gamma rays. The ability to detect radiation across the electromagnetic spectrum is vital for astronomers, as only a small fraction of the light in the universe comes in the visual part of the spectrum. That is why telescopes like Hubble Space Telescope are designed to capture images in wavelength invisible to the naked eye. The study of quantum electrodynamics has revealed all sorts of surprises too. When the physicist Paul Dirac was tinkering with an early version of the theory in the late 1920s, it suggested that a positively charged version of the electron existed, the portal to a whole new world of antimatter that mirrors all conventional particles with ones of opposite electric charge. Why our world is made of atoms and not anti-atoms has to rank as one of the most fundamental mysteries of physics. We use electromagnetism on large scale in many forms in our daily life. Devices that produce an electromagnetic field when electricity is applied are called electromagnets. One important application of electromagnetism is on electric appliances that use an electric motor. Electric motor consists of magnets that create rotational movement when electricity is supplied. Magnetic recording devices like computer hard disk drive and video cassette recorders also rely on electromagnets. Tiny bits of metal inside these devices are being magnetized in order to save and retrieve information. Electromagnets are also used in doorbells and speakers. Electromagnets are widely used in various fields and industries, and they play a very important role in our daily life.